Okay, so who stated that in a chemical reaction, atoms are combined, separated, and rearranged? Yeah, good. Dalton, good. John Dalton. Okay. He also said atoms are solid spheres. Remember I said Dalton, you were a ton if you're solid. Who discovered the nucleus of the atom? Yeah, go ahead. I don't want to say your name. Yeah, go ahead. Oh, yeah. Rutherford, yeah. Remember the gold foil experiment? Yeah, I left that chain at home. I was gonna bring it, but you know, I left it at home. So next time. Stated and like that was the gold foil experiment where like the alpha particles, most of them went through the foil, but every so often one would bounce back because it was hitting that really solid but tiny nucleus. Stated that atoms of a particular element are all alike. Who said that? Basically that we have like kind of different kinds of atoms, and each atom in that kind would be alike. Yeah, go ahead. Nope. Democritus. I mean, he said something kind of, but he said like a stone only had stone atoms, and that those atoms in the stone were not part of anything else. Yeah. Also Dalton, yeah. So Dalton did and said a lot of things. This would be another one of them that he said. Okay. Discovered that atoms of each element contain a unique positive charge in the nucleus. Who helped us figure out the positive charge in the nucleus? Yeah, good. That also is going to be Rutherford. What was that? Nope. I wish. That's also going to be Rutherford. As much as I would love to write J.J. Thomson on the board, it's Rutherford here. Okay. We got like 3 more?
Yeah, we got 5, 6, 7.
5, 6, 7. Okay, who discovered the neutral particle in the nucleus? Yeah, go ahead. Back. Chadwick. Your boy Chadwick. Remember Chad from High School Musical? New Bay. New Neutron.
Who the heck?
Chad. Okay. Discover the charge of an electron.
J.J. Thomson.
J.J. Just couldn't contain herself. Okay. J.J. Thomson. Just kidding. J.J. Thomson. Okay, that he did the cathode ray tube experiment for that, where the beam bent towards the positive plate, which opposites attract, right? So if you're bending towards the positive, that would suggest the electron has a negative charge. Who was the first to state that all matter is made of indivisible? Let's get hands here. Let's get our hands up. Yeah, go ahead. Democritus. Yep. Remember, he gave us a demo of the atom. Okay.
Everyone except for Niles Bohr.
That's true. I left Bohr out. He's too boring. All right. Okay. Okay, moving on. So we get first 7 of the formative. We got those filled in. Friday morning, we still here? We got it filled in.
No, everyone's gone.
Make sure we get these filled in. All right, and then turn to your notes. Find the how to measure lesson. So it's you know, same order. It's not out of order this time with the packet. All right. So how to measure. Here's your first slide. Why is that your first slide? That should be your first slide.
Yeah, that is.
That's your first slide?
Yeah.
I hit you with that first?
It shows the target.
Okay. I mean, sure. Why not? All right. Accuracy and precision. I don't know why it's the first slide, but whatever. So in science, there's accuracy. Oh, I know. I switched the order. I don't know. Accuracy and precision. Now, in like everyday speak, a lot of people will kind of combine both of those words and use them as like synonyms. But in reality, accuracy and precision, they mean different things. If you are accurate, you are nearing the value that is accepted. In other words, accuracy is just saying you're getting where you want to get at. So, seeing a lot of people not writing on how to measure. Here. about J.J. Thompson? Okay, so accuracy, you're hitting what you want to hit. You're achieving what you want to achieve. Precision is just like consistency. So maybe in a word, accuracy is like your target. You're hitting what you want to hit. Precision is more about your consistency. Okay? In other words, you can be accurate but not precise, or you can be precise but not accurate. So, for example, if we look at these what am I blanking on? The target board? Targets? If you were bottom left here, high accuracy, high precision, this would be high accuracy because you want to hit the bullseye when you're playing darts. It is also high precision because you consistently hit the bullseye. Okay? Now then, looking at the second picture, this would be low accuracy because, like, what are you aiming for here? Like, you're not near the bullseye. It's high precision, though, because at least they're consistent. They're just, like, consistently bad. Okay, all right. Going to our third one here, high accuracy, low precision. All right, come back to me. Guys, what are we doing? Third picture, high accuracy, low precision. High accuracy because, like, yeah, that's decently close to the bullseye. That's not bad. But they're not very precise because they're kind of all over the place. They're not consistently in the same spot. Then the final picture, low accuracy, low precision. They are neither near the bullseye, nor are they, like, consistently missing. They're still kind of all over the place. Okay. All right, so we got this filled in. Okay. Moving on to the next one now kind of moving into how to measure. So the first thing whenever you're measuring something, you want to write every digit that you can read from the measuring device. Meaning, if I look at this ruler, I can read a 1, I can read a 2, I can read a 3, but I can read, like, there are tick marks for more than just 1, 2, 3, 4. I can also read, like, a half. I can read a quarter. I can read all the way to, like, a 10th place. So if I'm going to read the measurement here, you get to when you're looking at this, you find what you know for sure. So what do I know for sure here? In other words, like, what does this tick mark represent? Anybody know? What would this specific mark right there, what does that represent? That would represent, this would be like the 0.9 mark. Okay? And you're in between 1 and 2, so we know 1.9. That is what we can clearly read from the ruler. But then you get, and this is the key thing, really make sure you're focused. This is where people start missing this. You then get one guess, meaning one digit you can guess. So you know 1.9, then you get to add on your guess. So because if you look here kind of closely, it looks like it's a little past 1.9. Maybe you might say it's 1.92. Okay, that's acceptable. So 1.92, that's a correct answer. If you said 1.95, 1.94, or even 1.90, all of those would be acceptable measurements here. Okay? So again, the point is you get one guess, but also you don't just you can't do this. You can't say 1.923. Why though? Why can't I add another digit there? Why can't I say 1.923 or even like 1.920 or 1.924? Why do I have to cut myself off at that, this would be the hundredths place? Yes. You already guessed once, you'd be making a second guess, or you're going to keep going further, a third guess. You only get to make one guess. All right, so moving on here. So 1.95 is what I use, but again, that 5 is my guess. 9 is measured. 5, or in our case 2 here is a guess. Okay, so let's look at another example here. Well, first, to maybe point out the obvious, the more tick marks there are on a ruler, or the more digits you see, like whenever you're measuring something, the more precise something is. So, for example, this top ruler, we would say that's less precise because there are fewer tick marks than the bottom ruler that has more tick marks. Okay? So, again, the amount of digits you can use is going to depend on the precision of the tool that you use. Okay? Good here? All right, cool. So let's look at a couple examples here. Who could give me an acceptable measurement for this top ruler? It's okay if you're wrong. Take a look at it. So raise your hand. Raise your hand. Yeah, go for it. 10.25. 10.25. Love it. Now, the reason why that's an acceptable answer is because we know the 10, like you clearly see a marker for 10, but you also clearly see this right there. That would be the 0.2. You also see the 10th decimal place. So then his guess was the 5. So what would be another acceptable answer you could say here? 10.25 works. What would be another one? Yeah. 10.26, right. You could say 10.26. In other words, you could say 10.20, 10.21. The point is, once you get past that 2 spot, you then get your guess. Okay? So again, my point isn't really like, can you tell that's 10.2? It's a little bit of what I'm trying to help you figure out. It's more, do you understand how many digits you can report to when you measure? All right, what about this bottom one here?
8.6.
What did you say?
5 points, sorry, 5.3.
Huh?
Sorry, I'm not.
No, it's okay. Now, 5.3. If you put that on a test, that would actually be wrong.
Oh.
But why though? Because like I agree, like that looks like it's 5.3. Like, but this is where I need you to focus, because this is where people they get the first. They're like, all right, I think I understand this, but then they're like, make sure you understand why that's not accurate. Why is that not? Who could explain that for me? Because it just isn't. It's frustrating that's not, but that technically is not right. Okay. You didn't make a guess, right? In other words, you sold yourself short. You actually can report your measurement to more digits than that. So how could you adjust this? Because you know 5, you know that 5 there, you know that tick mark there, that's 0.3, you know those 2 spots on the ruler, then you get 1 guess, so what could you say? 0. Exactly. You could say 5.30. In other words, you could say 5.31 or 5.32, but if you truly think it's dead on the 0.3, just add a 0. There it is. So it's a little goofy, but that's just kind of.
What if it's 5.29?
You could say that, yeah. So say you think it's good point. You think it's a little not like a little behind the 0.3. You can say 5.29. You just can't say 5.2. You want to give yourself another digit.
So, if it's all like based on guess and like preciseness, then what's going to be the answer for these formulas?
Give me one second.
It's like you could guess multiple. If you could guess multiple like numbers and like.
I don't mind. It's for sliding stuff. It'll show up on it. Yeah. you can maybe try hitting the volume button. Like, I got like a meter stick. Okay, could you say your question again? Sorry.
If it's all based on like
Here, give me a second. Guys, let's refocus. We got a question.
if it's all based on like guess and like there could be many numbers on it, so what's the correct answer for like performing it?
Okay, good, great question. So then, questions asked like, when you're doing like when you're actually answering these questions, what would be like an actual answer you could put? And the answer is this formula was a nightmare to make. There's a bunch of answers like I had to put in, 5.30, 5.31, 5.32, 5.34, 5.3, 5.2. Yeah, like it. So there is a lot of answers for this. Yeah. It's probably, in hindsight, I probably should have just made it on paper and pencil. I don't know. But it's already made, so might as well just use it. Okay, let's keep it moving. 3 more here. So once we start filling these in, be ready to write. So you should be flipping. I think you're on a new page. What? That's the last page?
Yeah.
Oh. Well, so I guess let's let's just do these though. Top one. What do you think? The notes are pretty short today. There really isn't that much more to talk about with it.
7.
Here we'll get hands. Yeah, very back.
Can I come up and try it?
Can you come up? You'll be on camera. I mean, I don't know. Sure.
Let's go. Is this like the first person on camera other than you?
This is yeah, actually it is.
Oh, so it's a historic moment.
Hey mom.
What's up?
Yeah.
Hey mom. So it's 8. So it's like I think it's like 7.99.
No.
Yeah,
Nope.
yeah. What?
You said 7.99. I hear you. It's really close to 8, and it's not quite there. But that's technically wrong.
Oh, it's technically wrong.
Technically wrong.
Wait,
It's technically wrong though.
It's just technically
2
wrong.
guesses?
You made 2 guesses because you know the
Oh.
7, you know the 8. That's all you know. You don't know the 9. There's
Yeah.
no like 0.9 tick mark.
Oh, so it's just 7?
But then you get 1 guess because you know 7. But then you get to guess.
9?
There you go. 7.9.
Oh, so I only get 1 guess.
You only get 1 guess.
Ah, all
All
right.
right. Does that like everybody see that? Because
I'm seeing
you're
it.
like everybody. It's okay. Literally everybody does that. They're so used to like using 2, and then they get to that.
It's less precise.
It's less precise, exactly. The reason why is it's less precise, even though, guys, it's not very. You might have to drop out of school now. And we never saw him ever again. He's just.
Where are these both?
No, but really though, everybody does that. Really focus. Everyone does that because 7.9. That's obviously not what it is. But what the point we're trying to get here is like talking about how precise your ruler is, and it's not precise enough for that. Okay, so then coming to this one, what would you say? Raise your hand. Yeah.
0.89.
0.89, sure. Okay? Because again, we know 0, we know 1, so that's where the 0 comes from. You know the 8. This would be the 8. Then you get to guess 1 digit, and you guess the 9. You guessed it was just behind the 0.91. Okay. Again, you could say 0.91, 0.90, whatever. All right, last one. What we got?
8.25.
8.25, yep. That would be one of many correct answers. So again, you know 8. You know the 2. And then, so then you get your guess. And yeah, I would say it's between the 2 and the 3, so you could say the 5. But if you said 8.20, even though I disagree that I think it's clearly passed, I technically wouldn't count that wrong. Because my point is to see, can you record your answer to the correct number of digits? That's really kind of what I'm trying to get at, more than just measurement. Okay, so let me stop the recording.